we're going to differentiate the square root of 4x minus 5. If we consider the square root of 4x minus 5, using our knowledge of indices, we can say this is 4x minus 5 to the power a half. Note at this stage we have not differentiated, so this is still y. We're going to apply the chain rule, so let u be equal to 4x minus 5. If we do so, y will be equal to u to the power a half. Du dx here is equal to 4, and dy du is going to be a half u to the minus a half. We form our chain. Dy dx is equal to dy du multiplied by du dx. This is a half u to the minus a half multiplied by 4. A half times 4 is 2, and we have u to the half. We know u is 4x minus 5, so it's 4x minus 5 to the minus half. We've done the differentiating, but we could tidy this as 2 over the square root of 4x minus 5. Let's look at the second approach. Once again, y is 4x minus 5 to the half. We can see here that the inside function is the 4x minus 5, and the outside function is going to be just x to the half. If we differentiate this, treating the inside function as if it is just x, then we get a half times 4x minus 5 to the minus a half. Remember, x to the half would become a half x to the minus a half, so we're treating the bracket as if it is just x. We then have to multiply by the differential of the inside function, which is 4. This is 2 times 4x minus 5 to the minus a half, and we can tidy that as 2 over the square root of 4x minus 5. By now, you should have seen enough examples to try some of these in your head. With a little practice you can do this, and it's important to be able to do so, since often differentiating expressions using the chain rule is only part of a larger problem.